Hey guys, it's Simon and welcome back to my LibGDX Kotlin RPG tutorial series. So in the last part someone asked if I could make another video about pausing the game. So how would that work? He wanted to achieve that when the inventory gets opened up, that the game is then paused in the background. And I will show a more general approach in this video. So I will show you quickly what we will do. So we will completely pause the game, meaning that when we press the P button for pause, then we will see this little pause information first of all, then the background gets a little bit faded out, let's say. Also the music, maybe you don't hear that, but also the music and the sounds get paused. And when we unpause the game, so when we resume it, then the music will continue from where it stopped before, same for the sounds and everything else. So also we can, for example, in the middle of an animation, like you see here, and also still pause the game, so the animation gets paused then, and when we resume, then everything continues, also damage and also the animations of the UI and everything is correctly paused and resumed. And I think when you understand this concept or how I solved it, then you can also adapt it to whatever you need. For example, pause it, the game in the background when the inventory gets opened up. And when I implemented that, I actually found out it's not as straightforward as I thought it would be, because we are using a stage and there are some special things when it comes to this fading out effect that I showed you before. But let's talk about that later. Also, this is the way I solved it. So how I usually pause and resume the game. I looked a little bit in the internet what other people are doing when they try to pause the game. And in my opinion, some of the solutions simply won't work in a more complex game. So for example, I saw one of the solutions is that in the render method that people simply set the delta time to 0, and in their game that paused everything. But this is not correct in our game. For example, music and sound would not get paused that way. Also in our special case, you could then still, when you pause the game and you press, for example, the attack button, then the sprite would still stay swap to the first frame of the attack animation, because our state system will still trigger the state change, and with that we also will change the animation. So all of that is not really a good solution for me, so that's why I implemented a little bit differently, and this is what I'm going to show you in that video. Okay, so first of all, let's go through it step by step. So what would be a first idea what we could do when we want to pause the game? I want to show you some of the approaches and also the problems that come with that, and then we improve on this solution to make it better and better. So maybe a very naive approach that you might think would be simply, so as long as the game is paused in the render method, we simply return immediately because we don't want to do anything. So let's quickly simulate that. So let's start our game in the debug mode, and then we will simply comment out the code here. So this is our game currently drawn, everything looks good. And now let's imagine we would have here a return statement when the game is paused, meaning that nothing of that gets executed. So let's quickly replace the classes in the debug mode. And what we will see is when that is finished, is that suddenly our screen is black, which we don't want, because we still want to have our scene, but we want to have a static image. So first of all, why is the screen getting black? Also, you might hear that the music is still continuing. So this is also one of the problems. So simply commenting out the code here won't work. But let's find out, so why is the screen getting dark? What is the problem here? I'm not sure if I explained that, but this is coming from the game application itself. So from KTX game, when we check out the render method, there we see something that there is a clear screen method called. And what is clear screen doing? This is just some OpenGL stuff to remove everything that was rendered in the previous screen and start again from an empty screen, let's say, which gets cleared with a specific color that you define here. And then the entire screen gets filled with that specific color. And why would you do that? So this is actually necessary and important that this is happening, because you can imagine rendering a specific scene is actually nothing different than drawing on, you can imagine it like an empty canvas, and there you draw the different pixels on it, and this delivers us then one specific frame. And of course, when we want to draw the next frame, we don't want to adjust the pixels of the previous screen, because that would be quite difficult, especially when it comes to movement. Instead, what we do here in OpenGL, we simply clear the entire screen, so we clear the canvas, and then we start drawing again and again. So that's why we actually would need this clear screen. You can try out yourself when you simply override the render method and when you remove the clear screen method. And for example, then immediately return your screen, you will see that the image then actually remains. So the last frame that was rendered, you will still see that. But there is another problem when you then resize, for example, your window during this pause event, then the rendering will not be correct, because of course it's the frame that got rendered in a specific resolution. And when you then resize your window, then this frame, which does not get re-rendered in that specific scenario, is then also not drawn correctly. So that would be another problem. So with that, we already know we cannot simply return here immediately. We need a different approach to solve that a little bit better. Also, what I mentioned before, and we heard that maybe in the video as well, that the music is still playing, and that this is also what we don't want. We actually want to pause the music and then resume it later on. So how can we solve all of that? So the way I do that is usually that I go through all the systems of our entity world. So there we have all these different systems, and then I need to identify, so what are the mandatory systems that I always need. And what I mean with that is the systems which are necessary to render the correct result of a scene, but without stepping or moving forward in our game simulation. So for example, we don't want an entity spawn system, because when the game is paused, I don't want to spawn any new entities. Same, for example, for collision, we don't need that. We don't want the movement, we don't want attacking. So there you can go through step by step and see what kind of systems, or think about it, what kind of systems you need and what kind of systems you don't need. And for example, we can already imagine, so the render system would be useful, that this is active all the time because we still want to render something. The debug system could be useful, maybe if we want to debug certain things still. The animation system, I think in our case, because that one is necessary to set the correct frame of a sprite. So I don't know, for example, I could imagine in the inventory system, for example, when you move around the items, maybe you open up an item with for example, a bag opens up 3 new items, then you still need the new frames of these newly created items, for example, and there the animation system could still be useful, that one is at least active. Yeah, and other things, maybe camera system as well, to center the camera correctly, so things like that. And what I do here, so let's implement that quickly. So what we want to achieve basically. So let me put that here above the render method. So we want to have something like a function which pauses our world. And there we pass in if we want to pause the world or not. And then we have some like mandatory systems, as I mentioned. So this is the systems that we still want to have active no matter what, and those would be, for example, the animation system, then the camera system to correctly center the camera, for example, if a resize and everything is happening, then the render system to still draw our scene, although it's paused and a static image, let's say, we still want to render it live. Especially when it comes to resizing and everything, that still everything is rendered correctly. And we also want to keep the debug system, which also could be useful. And everything else, we don't need that, so we can deactivate that. And how do we do that? So simply from our world, we can get access to all the systems. There we filter then for all the systems which are not in the mandatory systems. Not the Java class, the normal Kotlin class. So with that, we get all the systems that we want to pause. So for all of those, we then set the enabled flag, and we actually set it to not equal of the pause information that we pass in here. So if we pause, so if pause is true, then enabled gets set to false, which means that the system is no longer processed when we call entity world update. And that's it. So this is usually how I solve it. And also in maybe a more complex game where you have different screens, maybe different entity world as well with different systems. So there, just think about for every specific screen, what do you really need? And then just deactivate all the systems which are not necessary during a pause. So this is the first step. Currently, we don't call that, but we come to that then in a moment. Then, as I've shown at the beginning of the video, I wanted to somehow fade out the game a little bit and show this pause information when we press the button. And I tried out different things, and I was actually a little bit surprised because it did not work the way that I have imagined it. So normally what you could do, yeah, let me show it here. So normally what you could do when you have your sprite patch, so all of our stages, we know they have this patch, and there you can usually set a color. And for example, something like this, so a little bit grayish, and then maybe an alpha value of 0.5, something like that. When you set a specific color before you render things, then everything that gets rendered, so all the different sprites, gets then actually, yeah, let's say tinted with that specific color. So they would be a little bit transparent and a little bit darker, for example, than they normally are. But this does not work with Scene2D, where I was a little bit surprised. And the reason for that is that some of the actors, and we have implemented one of those, so for example the flip image, where you can remember we have taken over the code of the normal image code for the drawing part, and then simply flip the image if certain things are true or not. And in those draw methods of some Scene2D actors, there's actually the batch set color called with the color of that specific actor. So even if I would say the batch color is, I don't know, black with transparency of 50%, it won't matter inside Scene2D because they simply overrule my color with the color of the actor here. And yeah, that one took me quite some time to figure that out. So I did not know that Scene2D is inside calling this set color function. And also, as you see here, so red, green, and blue, I cannot really modify that. So I would need to go through all the actors of the entire scene, set all the colors, and then revert them to their previous color. And as you can already imagine, that would be super complex and not what we want to do. So I skipped that approach with Scene2D. Also this one here, so as you see here, there would be something to modify the alpha value of the actor with this parent alpha, but I also tried that one out. So I simply set then, for example, from the was it the game stage? Yeah, and there the root, and there you can set an alpha value, I think, but this also did not render the way I expected it. So it's a little bit weird with Scene2D in that case. So this is definitely for me one of the downsides when you use bigger libraries, let's say, and not implement the render logic yourself, like directly drawing the texture regions or the sprites with the sprite batch directly. Then you also get a lot of other functionality that you maybe don't want in certain circumstances. And here in that case, I don't want what Scene2D is doing, but I cannot prevent it from doing that. So that's why I solved it differently. And the way I solved it simply is by creating then a new view, so like an overlay of our user interface stage. So we had last time, I think, this inventory view that gets simply drawn on top of our game, and now I simply created a new pause view, which also simply is then on top of the game. And this pause view has then a dark texture as a background. We see that in a moment, and this pause label information, and that's it. And initially I wanted to skip this part because we have seen all of that already, but I show you some special thing that we did not see yet, and that you learn something new, how you could create very simple textures dynamically inside the game. So this is what we are going to do now next. So for that, let's create a new view. Let's call it PauseView. And this PauseView takes in a skin, and it extends the K-table and the normal table of Scene2D, which takes in our skin. And this is a really, really simple overlay. So what we want to have, we want to fill the parent. So we want to fill the entire stage so that this pause view is really stretching over our entire scene. Then we simply want to set the background of our table, so that this is this dark background texture that I mentioned before, that everything looks then a little bit faded out. And we also want to add the specific label. So this one we will do in a moment. And we also want to add then a label, and there we say, for example, pause. And as we have seen in the initial video, to also have an example there, we want to have it in a red color. So we say red, green, blue, so like that. So that this pause information is also in a red color. And there we need a new label style, because both of our label styles currently have a background texture, and that one we don't want in that case. So we simply want to have a large label without any special background textures. And yeah, I think that's almost it. So our label cell, we want to expand it and fill it. I need to import then all these methods, and also the text alignment should be then finally centered like that. So okay, so let's first of all fix the imports here below, and let's also create now this large label style that we don't have yet. So here after title, let's create a new one. Let's call that large. And below where we have the different labels, so there we'll add a new one for our large skin, where we use, for example, the big font. We don't want to have a color, and we don't want to have a background. So it's as simple as that. And that's it. I think in the real example, I also created a new font, which I made a little bit bigger, but I think this is not necessary in this video. You can imagine that already, because we learned that. So I think I created here a new version with a scaling of 0.75, so a little bit bigger, but I will skip that here for now. Okay, so this means in our PauseView, we have now already this centered label, and we would be missing now this background. Also, of course, we are missing the Scene2D extension, but with the power of video editing, I will simply now show you this final result of the method and don't implement it again, because we did that already multiple times. So this is the small extension, the Scene2D DSL extension, that we can then create a pause view inside this actors extension function of LibKTX to easily create the pause screen. But the important part is now, so this background. So how could we create that or set that? So one way, of course, is that you simply create your own texture with an image program, and then set the color and everything the way you want it. But for a very simple one, so in this case, it's really just a texture with one specific color. So we actually just want to set the specific color on top of our scene. And there we can create a texture on demand by using a so-called, or creating a so-called Pixmap. And the Pixmap, as the name suggests, is simply a pixel map. So you have a grid, let's say, of the different pixels. You can define the size of the Pixmap. We see all of that in a moment. And then you can draw on that specific pixel map on this grid. And what we want to have, we simply want to have a pixel map with a size of 1. And that 1 pixel of this texture, we set then to the color that we want. And because of the set fill background, this texture gets then scaled up across the entire scene. And also we want to, of course, dispose this newly created texture. So we will store it inside the skin. And to identify it in the skin, we need, of course, a key first of all. So let's call that a Pixmap key, for example, and that would be our pause texture Pixmap. What we are then doing, so if our skin does not have the Pixmap key, and this is a texture region drawable, so this is always this class that we are working with in Scene2D. So if it does not have that, then we are going to add it. So we are adding something new to our skin, which is the Pixmap key, and this is a texture region drawable. And the texture region drawable, as we know, requires a texture, and the texture can take a Pixmap as an argument. And the Pixmap takes a width and a height. So there, as mentioned, we just want to have 1 pixel for that. And it takes a specific format. So this is what kind of pixels and the colors are supported. And what we want to have, so we want this RGB 88888, so with the 4 8s, which means that it simply supports, I think, any color and any alpha value. Some devices won't support that, then you need to choose one of the other formats, but I think nowadays the 4x8 I think should be supported by almost all devices, from at least from what I know. And then we want to adjust this Pixmap, so we call here apply, and the Pixmap has certain functionalities to draw things, so you can draw a line, a circle, a rectangle inside this grid of pixels, and we simply want to draw a specific pixel at the coordinate 0, 0, so this is our only pixel that we have, and the color that we want to use, so there, as you see as an argument, it's an integer that we need to pass in here, and what we are going to pass in here is our RGB A88888, because that is the format that we specified for our Pixmap, and there we use, for example, that specific color, and that's it. Let me zoom in a little bit. Sorry that I forgot that. And yeah, so with that we have now this pixel map and also this texture in our skin, and because we add it to the skin, it will get this post. And finally we simply need to set it here as a background. So from our skin we want to get the Pixmap key, and this is a texture region drawable, and that's it. So this is our PauseView. So very simple again, I repeat it. It's a table. We create a texture with just one specific pixel that we draw in a specific color. With that specific color, it will then look like our main game is a little bit darker and faded out, let's say. So this is why we use that. We set that as a background. We fill the parent so that the table stretches over the entire scene. And we will also add this label that we have the information that something is paused or not. And finally, the only thing that we need to do in our game screen, where we already set certain things for our user interface stage, and there we now want to also add the PauseView, which is initially visible. It would be false, but just that we can test it for now, let's set it to true so that we already see how that looks like. So let's try that out. Okay, looks good. So as you see, so we have this pause information, and our pixel map that we created on demand gets stretched over the entire screen, and now everything looks a little bit darker, and yeah, in my opinion also looks a little bit like it's faded out, but yeah, so that's it. PauseView done, looks great. And as mentioned, we don't want to have that, of course, visible from the beginning. We want to have that not visible from the beginning. So let's switch now to our player input processor so that we can now toggle this PauseView. So this would be the first step that we want to do. So let's switch to our player input processor. And there in our key down method, there we want to have another key code. So we check if the button P is pressed. And when P is pressed, we want to toggle actually the game state. So from pause to resume, or from resume to paused. So we need to remember that in this controller. So let's initialize it, for example, with false. And whenever we press the P button, then P is equal, or paused is equal to not paused. And what I choose here again to notify now in our entire game logic that a pause event should happen, I simply trigger an event here. So what we need is our game stage, because that is the stage that we use mainly for to trigger game related events. So first of all, let's take that here as an argument. And then below here, so we have our game stage, and there we want to fire an event. And there, if the value of paused is currently true, then we want to fire a game pause event. And otherwise we want to fire a game resume event. We of course currently don't have anything which reacts to those events, but that one we will also implement in a moment. So step by step. First of all, let's create those new events. So let's go to our event file, and they are really basic. So they take no argument and simply extend the event class. I think we don't even need the brackets then here. And we also have the game resume event, and that should be it. Okay, so those are the updates to our controller. So we have this pause information that we will toggle when we press the P button, and then we fire a pause and a resume event, depending on what kind of information the pause variable currently has. In our game screen, we now need to pass in here our game stage as well. Yep, and that's it. So now when we press the P button, we will already fire those events. And now we need something that reacts to those events and finally call then our PauseWorld function that we did not call yet. And I refactored that a little bit. So initially I had everything in the game screen class, but thinking more into the future where you might have different screens, and yeah, most likely all of the screens will somehow follow a very similar logic when it comes to pausing and resuming. So that's why I refactored it a little bit to move certain areas to the game class itself and handle it in the game class. And then the screens only need to implement their specific pause and resume behavior and don't need to remember if currently something is paused or resumed. So all of that, so the event handling itself will happen in the game class. And what we will do there is, first of all, we move the stages to the game class and also fix something there, which I did not notice during the tutorial. But there's actually, it's not a problem, but something that is not very nice when it comes to those two stages. So first of all, let's move that now, or let's refactor that a little bit. And you can do that live with me so that you see a little bit how I refactor that specific part, for example. So first of all, we want to have our game stage and UI stage in the game class. And this won't work because, so with the equal here, it won't work because we need an OpenGL context in order to create a stage, because the stage, without calling here or without passing the last argument here, will create a sprite patch. And the sprite patch requires, from what I know, an OpenGL context. So we cannot do it like that, but thanks to Kotlin, we can simply use a bylazy, which is then working. So the first time when we then access the game stage or also the user interface stage, they will then get initialized. So there we can use this bylazy, which is great. And since our screens will need access to the game stage and the UI stage, we can remove the private here. And I already teased now a little bit, so we are actually currently not passing here the sprite patch as an argument, which means that our game stage and also the user interface stage will create their own sprite patches internally. And this should be avoided because the sprite patch is usually a heavy object, and you don't want to have a lot of those. So ideally just one, and in our case we actually really just need one. So let's create here a batch of type patch as well, also initialize that lazy, and we will create here a sprite patch, and now we pass that in here as the last argument so that we have here our patch available. So we reuse just one and don't create two of those. So this is a little bit of an improvement to what we had before. In the dispose function, there we now of course need to dispose our patch, and also we need to dispose here our game stage and our user interface stage. Okay, so in our game screen currently we won't have access to all of that, which is okay. We fix that in a moment, and we don't need to dispose the two stages anymore because that is now handled in the game directly. And also the resize method, as we see here, which simply resizes the stages, we also don't need that in our screen anymore. We can now do that also in our game itself. Okay, so our screen now needs the game stage and the user interface stage, and we could pass that in here, of course, when we create it. But during my games, normally the amount of arguments that the screen needs, so certain objects from the game itself, they get bigger and bigger, and it's then a little bit annoying when you need to adjust the code all the time and pass in a lot of things to a screen. So what I normally do, I simply pass in the game screen as an argument, so the game itself as an argument. And from what I saw, this is also somehow like some Android developers are doing it. So there they have this, I think, context, if I remember correctly, and out from the context they then simply retrieve the necessary things or the stuff that they need from the context. So in our case the context would be the game, and from this game now we can now retrieve the game stage again and also the user interface stage. And with that the refactoring for that is done. So the stage and the resizing is now happening on a more global state, if we want to call it like that, and this is our game application itself, so that the game itself, the KTX game. And what we are now missing, so to come back to that, now we want to react to the pause and resume events. So our game also needs to be now an event listener. Then we need to register it, of course, so our game stage, add listener, there we add our game, and we need to implement the handle method. So let's go here below and override the handle method. And there we want to react on two specific events. So when the event is a game pause event, we want to do something. When the game is when the event is a game resume event, we want to do something. And in all other cases, we don't care what happens. We simply return false because the game is not handling it. And what I do here now is also something, let me quickly show you that. So a screen also has its own pause and resume function, which normally gets called, for example, on the phone when your game is switching into the background because you get a phone call, and then it gets resumed when you maximize it again. On desktop, I'm not sure. I think when you minimize it and when you open it up, it calls pause and resume. And I want to reuse those two functions, because I think it makes sense. So when we press the P button, then from our current screen, the pause function is called, and when we press P again, then from our current screen the resume function gets called, so that inside the screen we can simply overrule these methods if we need to, and then call whatever logic we want to call when when the game gets paused or when the game gets resumed. So what we do here, back in our game, so here when a pause event is happening, from the current screen we call the pause function, and when the game gets resumed, then we call the resume function of our screen. And with that, so let's keep it simple for now. There will be something added here as well, but for now let's keep it like that, because now in our game screen we can override the pause and resume function, which we did not implement yet. And they are very simple currently. So pause is nothing else than calling pause world with true, and resume is the same, but calling it with the false argument. Okay, and what we want to do, of course, here, which was missing before, we want to show and hide now this UI view that we have added before. So from our user interface stage, we get all the actors. We want to filter for a specific instance. So we want to filter for our PauseView. This is also a more elegant approach than what we used last time. I think there I used an index to access the inventory view. So with that one here, so filter as instance, in my opinion, is easier to read and also safer. And there we simply want to get the first one of these pause views, so there should be only one, and that one we set visible to whatever the pause argument here is. And that should be it. So let's try that out. So now when we press the P button, we should get the pause view overlay, and also from our world, most of the things should already get stopped. And when we press P again, then we should resume our game. So what we already see, so when we pause, nothing is moving again. Also, I cannot move around, but we still have the animations. So this is one problem that we are going to fix in a moment. And when we press P again, then we resume the game and everything can also move again. So two problems remain. First of all, animations are happening, which we most likely don't want. Maybe you want that. It's also a little bit of a nice and funny effect, I would say, but I implemented it the way that the animations also get stopped. And the second thing is that our music and sound currently is still playing. That one we are going to fix last. So for the animations, it's quite easy to solve, and again, it's handled in a very general way in our game directly. So there, let's implement now a pause flag, which is initially set to false. Let's call it paused. And when we receive a pause event, we set it to true. And when we receive a resume event, we set it to false. And now what we want to do, we want to overrule our render method of the screen, which, let's quickly check it out. It's very simple. It clears the screen if you want to do that, and then it calls render of the current screen with the graphics delta time. And that piece of code here, that one we want to adjust. So we take over the entire code here. And in our case, we always want to clear the screen, so we can also remove that specific check. And this delta time now, that is the one that we are going to adjust, because if our game is paused, then we simply want to have a delta time of 0 so that nothing moves forward. And in our case, for the animation system, that means that the animation does not play anymore, because it simply updates with a value of 0, which means it does not update at all. And if it's not paused, then we are going to use that delta time here. And finally, in the render method, we now pass in this new value instead of the graphics delta time. And with this little adjustment, now the animations also should be stopping when we pause the game. So let's move up a little bit and let's press P, so we see now the animations also stop. It's the same when we are in the middle of an attack, for example, as you see it here. This also gets then paused, and when we resume, then it continues correctly. So all of that is now looking great, and we are almost done now. The final piece that is now missing is pausing and resuming the sound. And there, I think at least on the phone, when the application goes into the background, it actually already stops the music and the sound, but I don't know how to trigger this functionality. So that's why I always ended up implementing it myself, which is not that difficult, and I will show you that now. So what we need to do, we have a system for that, and that's the only place where we need to adjust something now. So in this system, first of all, we need to remember what is our current music that is playing. So initially it would be null if there is no music set at all, but later on when we call the, where do we call this music stuff? So here exactly, so when we get the map change event and we play a specific music, now instead of a local variable, we will set our music variable, which of course needs to be a variable and not a constant. And here it could be null, so of course it wouldn't in that case, but there is this compile error, so let's just add the question mark so that that one is working. So now we remember the currently played music, and we can now of course pause and resume it. And this is also already ideal because our audio system already is an event listener and handles certain events. So what we can do here, so if we receive a game pause event, we do something. And if we receive a game resume event, we also do something. So for the music, it's very simple. So if there is a music, we call pause. And if there is a music in here, then we simply resume it. And it's not called resume, it's here simply called play. So play will resume the music. So that's already working. So let's quickly try that out, but pretty sure that this is already working. So now when I press P, yeah, music is gone. And when I press P again, it resumes from the location or the position where I paused before. So music pausing and resuming is working. And the final thing that we are now missing is pause and resume of a sound, which initially in one of my previous games, I thought was very complex because when you create a new sound instance, where do we have that? Let me quickly check. So new sound in here, that one gives you back a sound instance, and when you call then the play of a specific sound, it will deliver you back a long, so which is the unique ID for that specific sound instance. And initially I thought I would then need access to all the different sound instances that I have, and then call resume with the sound ID and also the pause with the sound ID. But luckily that is not needed at all, and at least in my game it was always sufficient that you can simply call pause and resume on the sound itself. So we don't need to pass in the long ID. The sound class, as we have already seen here, has a pause and resume without an ID argument. And what that is then doing, it simply pauses and resumes all sound instances for that specific sound which are currently playing. And this is actually what we want. So pausing and resuming of sounds is also fairly easy. The only thing that we need to do is from our sound cache. So these are all the sounds which got loaded, and we don't care if something is currently playing or not, because we simply iterate over all of them. And there we call the pause function. And below here we call the resume function. And that's already it. So now when we would be in the middle of an attack, not sure if you can hear it because it's very silent, but so now I hear the swing animation and I paused it, and when I resume, I will hear the final piece of the swing animation. Yeah, perfect. And with that, I think that's it. So we are already, yeah, let's test it one final time. I think we have now everything. So we have the pause overview. We can pause and resume. We have this event handling. We cannot move, for example, when we pause. I cannot attack. I could attack, but nothing is playing. When I resume, it will automatically attack. This is how we have implemented that it somehow remembers when the player presses the attack button. And also any animation and stuff, also with the user interface itself. So as you see here, the text as well is not floating anymore. And yeah, so looks correct. Everything is working great. And with that, that's it. So as you have seen, I think pause and resume, it's not trivial. So you still need to think a little bit about how you want to handle it. And yeah, the way we did it here, I think, is good enough for almost any game. It's a very good and robust solution, and you can really adjust it according to your game, piece by piece, what kind of systems you need, how you want to do it. And also I like that the pause and resume function of the screen gets correctly called, and that everything is handled by the game itself, that you can then do specific logics if you need per screen. And with that, that's it. Thanks for watching, and see you in the next part. Bye bye.